Okay, so here I am going to calibrate the buck converter. Um, right now I haven't even tested it. This was just assembled moments ago. And so now I'm going to turn on, I have the track power connected to my DCS 100 directly to the bridge rectifier. So what I'm going to do is I'm going to connect a couple of leads to the output of the buck converter to my probes of my voltmeter, and yeah, then we're going to adjust the voltage accordingly. So just bear with me here. I'll get this stuff ready. Alright, so I'll turn this on to, I guess, 20 volts. Power things up. So that's looking at it just over 12 volts. So I'll take the screwdriver and dial that screw back, hopefully without shorting anything out, and see if we can get that dialed down some. Oh, it's going the wrong way, so we'll dial it towards clockwise. That's just under 12. Now the lighting came on at just about 10 volts. So as you can see, I'm barely turning this adjustable resistor. Let's see if we can get her around 9 3/4. There. Alright. So now we'll switch the lead. See here. It looks like there's just a little bit of voltage bleed, which is negligible. And then we'll take the magnet and see if we can get this to work. Look at that, power came on. And see if we can turn it off. There, it's off. On. Off. I'm flipping this as I go. See? Flip. She's on. Lights are on. Flip. Lights are off. Works perfectly. So I'm going to turn it on, and then I'm going to hit the power and see how slowly it drains the capacitor. It's not really meant to be much of a keep alive other than just to make sure that the lights don't flicker over dirty track. Well, it takes a few moments to get down there, milliseconds. Anyway, it's good. So we know she works. Now this, I do believe, is Well, it's just warm. It's not too bad. Must cool down pretty quick. Worst case, we put a heat sink on them, but I don't want to get into that. Anyway, thanks for watching.